Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna do a little exercise. It's basically we're gonna make like hopefully some kind of monad of spheres. Um, and colorize the sphere. So it's very simple. Perhaps at the end we gonna make an interesting arrangement of the sphere. You will see that sphere when we combine sphere together, it's a little bit more interesting to colorize each and every sphere, especially if they are kind of joined together. So I'm gonna do that real quick. So I'll call this SATAY sphere. I'm gonna start with a sphere. We're gonna reduce the resolution soon. I'm gonna start with a viewer draw first of all, and maybe 8 by 8 in the UV. 8 by 12 actually make a more rounded kind of UV, but it's 4 by 6. No, actually 8 by 8 should be okay. And the idea is to have a bunch of them, so you already know it. We can use random vector position, for example. For a test, make it 5. So yeah, it's actually as simple as that, but we want to combine them and join them into a single objects. Currently, if we bake them, they're all separate. We don't want that. In this case, we want to join them, so we can colorize all of them at the same time using vertex color. So we need to use matrix apply. And this guy should generate more points, but we need to also repeat the polygon. So repeat 5 times because we have 5, and we need to unwrap it. So we have like 5, 5 like that. And one more thing, we need to mesh join them, like just like a housekeeping thing. So now they're really like a single object. If I bake it, it's a single object. And if I randomize the seed and bake it again, they're also a new kind of arrangement, and they are single objects. This is the whole idea actually. And for each and every joined sphere, I'm going to give it a different color. And for that, I will use a B-mesh. So we are done with the viewer. I'm gonna try it with a B-mesh. Viewer B-mesh, and then just simply plug this guy in and this guy in. The number, I'll make sure they're correct. I'll have a single parameter to control the number of point position for each sphere and also for the least repeater for the edges. Now we can control the radius and increase the number, and they are still a single objects. Okay, cool. I'll make it back to 5, and gonna give it a color. I'm gonna switch to cycle render because we work in cycles. Blender engine. I'm gonna create a new material, and for that material I'll assign it a color, vertex color. So you see this is the diffuse, so that's the default that currently we have. This color, it can colorize each and every sphere with the same color, but we want a random color for each sphere. So for that, I'll use the attribute and Sverchok color, plug into this guy. Currently it's black because we don't have anything from Sverchok. I'm gonna assign this material for the vertex color. It's gonna be this object, and for this guy, the color, and actually for the color, we can try color in. HSV, color in, and it's currently okay. So we got so we can colorize every sphere now. It's working. One thing I want to do is to give it a color, each different color for the sphere. So how do we do that? So if we try to use range float, let's see, because we are coloring the vertices, let's give it a try anyway. The count range float from 0 to 1, plug into the hue. You can see that it's colorizing the sphere, but not in a way that you might have thought of. It seems to be colorizing them one by one. So they look kind of neat. Okay, let's do it again. You see, there's like some kind of order of sequence. And if you want to give it like a different color for each one of them, you need to kind of split the information depending on the number of vertices of each sphere. We need to be aware of that and then kind of split the number. I'll make it a bit clearer. Instead of using color in, I will use my own color input, list input, and use a vector, and let's have like 5 color and plug into this guy. So red, I'll give it this is red, blue, green, this is yellow, and some other color, cyan. So you can see the color is only colorizing the vertices, right? But we need to repeat it for each and every sphere. For that, we need to, I'll use the stethoscope for it real quick. And let's see, test the data, have a look at the data. Currently we have 100010. It's gonna be the RGB. Let me have a think first. Probably it's better to look at it with text viewer. Plug it in, view, auto update, have a look. It's all this value being repeated, but we care about the first 5. 1, 2, 3, 4, 5. That's our own value. You see, the rest of them get repeated for the cyan. So we don't actually want that. We need to count the vertices number, list length. For every sphere, we want to know the number of vertices. So apparently we have 50. So we need to list repeat. I think we need to unwrap it. Let's have a look. 1, 2, 3. I'll color this 1, 1, 1 and 0, 0, 0. So that's a bit clearer. 1. So that's not what we want. We want it to be 1, 1, 1, 1. Okay, that seems to be correct. This is the one that I want, and we need to list join them together. Okay, I think this is correct. Plug that in, and there you go. It's actually that simple, simpler than I thought. That's the number of vertices goes into this repeater. So list repeater and list join, this is important for what we are doing. So we have 5 color now for each sphere. If we actually have a different kind of objects per instance, per separate objects, we need to think again. But this is if you have like a single object like this sphere being repeated multiple times, and each one of them you want to have a different color. Remember that they are the same objects, but they are all like have separate elements, and for each separate elements we want to give it a random color. That's why we have this kind of setup, like we take our time to troubleshoot this. Now if we go back to this one, to the rainbow color, we can simply assign this number 5 based on 1, 2, 3, 4, 5 sphere. Hopefully that makes sense. If we actually use a random color, actually a random vector 5, plug into this guy, we're gonna get a result that we want. And this count should also be connected to the number of sphere. Let me delete that. So this is the total number of the sphere that we have. This should be connected to the total number of the color, and now we are good to go. So if no matter how many sphere we have, this will generate random color, and if we switch to this guy, this will give us like a rainbow color, all in order based on the creation of this sphere. Okay, cool. File, save as. And if we want to turn this into a monad, I think I will do that in the next live noding video. For now, I'll make, let's say we have a different arrangement of this guy. Instead of random vector, we turn it into put it into a line, for example, and the line should have the same number of points. This plug into that guy. You see, it's really simple to do. So we can have a line that's a line of spheres in that direction, in X directions, or we can rewire this guy, vector rewire X to Z, and we have it going up. And depending on the number of the vertices of the line, we get the duplication of the sphere. So yeah, see, that's really simple to do. Sphere, I think it's working correctly. So we have some kind of like a SATAY. You know, SATAY is a kind of food popular in Indonesia, Malaysia. It's where you have this you have a wooden stick and you put some food on it. That's what we have at the moment. And this guy, the nice thing about this guy is, you know, it's a contained in a single object. Okay, and let's say I'm giving it like a random color. Oops. See, range float. Okay. The counts coming from this guy. Okay. Let's say we are giving it a random color. Plug into this guy. Interestingly, the whole thing changed. Maybe because of the sfig call, but I thought they're no longer related. That's weird that this guy changed color, even though it should, in theory, like if we use a random color for 1, this guy doesn't change. Maybe they're still using the same data. Yeah, I'm not sure, but anyway, that's pretty much for this live noding. If you have any questions, suggestion, feedback, just let me know down below. Thanks again for tuning in. I'll see you in the next video.